Okay, so continuing with chapter 1.4, we've done one side of the limits. Now we're going to talk about the continuity of a function. The reason why this is in chapter 1 is because a lot of your calculus you'll see is going to require a continuity of a function to work. So here's how you tell if a function is continuous. Um, First of all, the non-calculus version of continuity is very simple. A function's continuous if there's no breaks, basically. So if you can trace the function and not take your pen off the paper, it's continuous. If there's one point that it breaks, it's not continuous. Even if that point is a vertical asymptote, not continuous there. So it's very simple concept, continuity. But the requirements or the definition is a little bit more complicated. So we're going to define it in terms of limits. A function's continuous on an interval if it's continuous at every point in its interval. So this definition of continuity defines what it means to be continuous at a point. And then if it's continuous at all points in an interval, then it's continuous along the entire interval. So the three requirements for continuity at a point is the function must be defined at the point, the limit must exist at the point, and finally, the value of the function and the value of the limit are the exact same. Maybe a little bit confusing, but let's look at it. So we're talking about continuity at a single point, like the point, arbitrary point C. That's what it's talking about. So f of c is defined. So if I see a function and say it's not defined at c, that could be an asymptote or it could even be just an open point. That's obviously not continuous. So therefore, this is a requirement of continuity. It also says a limit must exist. So say we had a function that looks like this. So here's a function that's actually defined at c, but you can see here the limit wouldn't exist. So even though it's defined doesn't mean it's continuous. The second item says the limit must exist. But that's not enough because, watch this. I draw a function now that the limit does exist and it's defined. So the limit exists. And it's defined, but maybe it's defined up here. So for this function, it's defined at c, the limit exists, but it's still not continuous. Why? Because this isn't true. The limit is this value, right? And f of c is this value right here. That's f of c. This is the limit. They don't equal, therefore it's not continuous. So to be continuous, all three of these have to be true. And so just one last example. Let's draw a function that is continuous at c. It can look like anything. At c here, you can see clearly there's the function is defined. Clearly the limit exists. And the value of the limit and the function are the same thing. So this function is continuous at c, but it's also continuous everywhere else. So we would say this is continuous everywhere. So that's a in-depth definition of what continuity is. I'm going to stop it there because we're going to get into examples after this, which is kind of a different track. So if you need to look at this video again or ready to move on, refer to the next video.